Welcome to the Explainer. There's this technology that's pretty much become the invisible engine of our world. It's in our homes, our cars, it's everywhere, really. And to get a handle on it, let's just kick things off with a question. Okay, so what do these three things, a car that parks itself, a massive nuclear power plant, and a super high-tech farm, what do they all have in common? I mean, they seem totally different, right? One's about pure convenience, another is about generating incredible amounts of power, and the last one, well, that's about growing our food. But there's a thread, an invisible connection that ties them all together.
And that's it. That's the secret sauce. They all run on automated systems. Seriously, from welding car frames to watering crops, this technology has become absolutely essential. So, the big question is, how does it all actually work?
Now, this is the cool part. Believe it or not, the principle behind all these super complex systems is actually, well, it's beautifully simple. We can break it all down into just three basic steps: sense, think, and act.
Okay, so let's get the official definition out of the way first. An automated system is a combo of software and hardware, things like sensors, microprocessors, and actuators that's designed to work all on its own without any humans stepping in. The key takeaway here? It's a mix of brains and brawn, hardware and software, all designed to do a job automatically.
So, it all comes back to this three-part mantra. You got to remember this: sense, think, act. First, the system has to sense what's happening around it, right? It uses sensors to grab information. Then it has to think. A little computer, a microprocessor, chews on that data and makes a decision based on its programming. And finally, it has to act. It uses these things called actuators to actually do something in the real world.
And this diagram really nails it. It shows that fundamental flow perfectly. You've got sensors providing the input. That's the sense part. Then a microprocessor processes it all. That's the think. And finally, actuators, like little motors or valves, create the output. That's the act. It's the same basic recipe every single time: sense, think, act.
All right, so now that we've got the blueprint down, let's see how this whole thing plays out in a couple of really different real-world examples.
Okay, check this out. The contrast here is just incredible. On one side, you've got a nuclear power station. I mean, about as complex and high stakes as it gets. And on the other, a massive automated irrigation system. They look nothing alike, right? But here's the thing. They run on the exact same logic. The power plant senses temperature and pressure, thinks with its control system, and then acts by opening and closing valves. The farm, it senses how much water is in the soil, thinks with its own controller, and acts by turning pumps on or off. Same principle, totally different scale. It's kind of brilliant.
But of course, like any powerful tech, automation isn't some magic wand you can wave. It's always a balancing act. You've got these amazing advantages on one side and some pretty serious disadvantages on the other. Just look at this number: 0.000001%. What is that? Well, that's the error rate for an automated system putting pistons into a car engine. Now, get this, when people did it manually, the error rate was around 1.5%. That's not just better, that is a monumental leap in precision. It's almost perfect. And you see these trade-offs pop up everywhere. The advantages are always pretty clear. It's way safer, for one. It gets people out of dangerous jobs, it's faster, it's more consistent. And a robot doesn't need a lunch break. It works 24/7. But there's always a flip side, right? The initial cost to set this stuff up can be huge. And because it's all computerized, it's a potential target for cyber attacks. Plus, they can really glitch out when they run into something they weren't programmed for. And don't forget, keeping them running perfectly requires some very expensive and specialized maintenance.
So keeping that balance in mind, where is all this technology heading? What's next? Before we look to the future, let's just do a quick recap of the most important takeaways here. So, what are the big things you need to remember? First, automated systems are absolutely everywhere, from huge factories to your local farm. Second, they all follow that super simple model: sense, think, act. It's the key to understanding all of them. Third, remember the parts: sensors for input, a microprocessor to think, and actuators to, well, act. Fourth, The benefits are massive, huge gains in safety and efficiency. And finally, never forget the trade-offs. It's all about balancing that high cost and the risk of unexpected errors.
And that really brings us to our final thought. Because the future of automation is all about artificial intelligence. These systems aren't just going to follow rules anymore. They're going to start to learn, to adapt on their own. And that leaves us with a really big, really important question. As these machines get smarter and smarter, what's the one decision, the one judgment call that you think should always, no matter what, be left in human hands? Something to chew on. Thanks for joining us on The Explainer.